For the next minute, just imagine walking through the remnants of a war-torn forest, stumbling across a bunker that's long abandoned and, well, overgrown. The air is cold, damp and still. Most would see only decay and rust. But, history enthusiasts know better. These structures hold secrets that were once cutting-edge survival technology. One of the most overlooked innovations is a lost World War II heat trap, a simple yet brilliant system that allowed soldiers to stay warm in freezing conditions while using minimal fuel. It wasn't fancy, it wasn't electric, and it certainly wasn't modern, but it worked better than most stoves, furnaces, or field heaters of the time. Today, we're going to explore how it worked, why it was so effective, and how the principles behind it can still be applied by survivalists, homesteaders, and anyone fascinated by practical wartime ingenuity. Understanding why World War II engineers prioritized heat traps over conventional stoves is honestly quite fascinating. During the Second World War, soldiers often spent long periods in cold, poorly insulated bunkers, foxholes, and temporary field shelters. Fuel was scarce, fires attracted attention, and even a few lost hours of warmth could cost lives. Engineers and field officers quickly realized that conventional stoves, while effective for cooking, wasted most of their heat into the air or through chimneys. They needed a solution that concentrated warmth where soldiers lived, slept and worked while reducing exposure to wind and moisture. That solution was a cleverly designed heat trap, a series of insulated chambers, strategically placed reflective surfaces and thermal mass that captured, stored and redirected heat with minimal fuel input. The system was simple in design but revolutionary in effect. It turned small, intermittent fires into sustained warmth that could last through long winter nights. For modern survivalists, the lesson is clear. Direct heat is not always the most efficient. By controlling the movement of hot air and using materials to store it, you can dramatically increase comfort and conserve resources. The genius of the World War II heat trap lay in how it integrated with existing bunker architecture. Bunkers were constructed with thick concrete walls that resisted external temperature swings. Instead of fighting these walls, engineers used them as part of the heating system. They created small fire pits or metal stoves in the center or corners of the bunker, then built channels and cavities within walls to circulate hot air. Thermal reflectors made from steel sheets or thick planks directed heat back into living areas rather than letting it escape through exhaust vents. In some designs, hollow spaces within walls were filled with sand or small stones to absorb heat from fires and radiate it slowly over hours. A practical application today is to think of any insulated space, shed, cabin or even tent as part of your heat system. Place a small fire or stove near thermal mass like rocks or bricks and use reflective surfaces to push warmth toward living areas. This principle, borrowed directly from wartime heat traps, can double the effectiveness of a single heat source. World War II soldiers often didn't have the luxury of large fires. A visible blaze could attract enemy patrols, and fuel was often limited to small bundles of wood, coal, or compressed peat. The heat trap design allowed these minimal resources to generate maximum effect. By funneling hot air through carefully designed pathways and storing excess heat in surrounding materials, the bunkers could stay comfortably warm with intermittent firing. The principle is simple. Heat is most useful when it remains where people need it, not when it rises and disappears. Modern survivalists can recreate this approach by building small insulated stoves or fireboxes in cabins, workshops, or temporary shelters. Even a small metal container surrounded by stones can act as a mini heat trap, radiating warmth long after the flame dies. The World War II example proves that efficiency often trumps size when survival depends on staying warm with limited fuel. Another remarkable aspect of the World War II system was improvisation. Soldiers used scrap metal, sandbags, spare boards, and even old helmets to enhance the trap's performance. Metal sheets reflected heat, stones absorbed and stored it, and sandbags acted as insulation for channels and vents. These additions were often created in the field, demonstrating a level of ingenuity born from necessity. For today's viewers, this is an important survival lesson. The materials around you can amplify a heating system without requiring expensive technology. Stones, bricks, scrap metal, and even packed earth can store and radiate heat when arranged properly. A simple reflective panel behind a small wood stove in a cabin, for example, can dramatically improve efficiency. The principles behind the heat trap — thermal mass, reflective surfaces, controlled airflow, and efficient fuel use — are timeless. Modern electric heaters and chemical fuel sources are convenient, but they can fail or be unavailable in emergencies. Understanding how soldiers heated their bunkers with minimal materials, maximum efficiency, and complete reliability provides a blueprint for anyone seeking sustainable warmth in off-grid living, survival shelters, or historical reenactments. These methods show that heat doesn't have to be complicated to be effective, and that clever design often surpasses brute force. By combining these historical insights with modern materials, anyone can build a low-cost, high-efficiency heating system for cabins, tiny homes, or field shelters. Even small spaces benefit from thoughtfully placed thermal mass and airflow control, principles that kept soldiers alive under extreme conditions. If you love uncovering forgotten survival technologies, learning from history, and applying old-world ingenuity to modern challenges, make sure you subscribe to In the Beginning. Share this video with friends who appreciate practical historical knowledge, and stay tuned for more deep dives into the technologies that shaped survival, war, and human innovation.